everybody. So I'm Nick. I'm a solutions architect. I'm also joined by Etienne and Renan, who's going to be, he's the product manager for this new service that we're going to be talking about today. And Renan is going to be telling us a customer story about cost optimization. So the story for today is, AWS provides lots of choices to you. We have lots and lots of instances, and I think it changes every month, almost literally. And so there's this sort of challenge of, you want to get the best performance, but you also don't want to get paged at night if you don't give it enough resources. So just double or triple it, and someone else's problem. But then that someone else's problem usually becomes, cost and finance. And so the question is, how do you take all these different options that you have and all the different inputs and variables and use that to reduce costs in your environment? So what we're going to talk about today is really, a couple things. One is, let's take a look at the total portfolio of EC2 instances and what that looks like. We're going to talk about, some of the things you want to think about. What are the variables and inputs on choosing an instance type? The exciting part here is we released a service yesterday called AWS Compute Optimizer. So it uses machine learning and CloudWatch metrics to help you make decisions and understand the risks involved. And then, Renan from Nubank's going to talk about how, as an organization, how they enacted change and did cost optimization and some tips and some organizational sort of things there. And then, we'll follow up and tell you all right, so you want to change your instance, what are some of the things you should think about? So there's a couple other breakouts that are worth checking out. And these are all going to be on YouTube. And this one will too, so the SlideShare and YouTube, usually within a day or two. They're getting pretty fast about those things. So you can check those out if you like. And from here, I'll take it over to Etienne, who's going to talk more about EC2 instances.
Cool, thank you very much, Nick. So, hey everybody, my name is Etienne Fon. I'm Senior Product Manager at EC2. So first of all, I'd like to talk a little bit more about the EC2 instance in AWS. Okay. So when AWS was first launched, when EC2 was first launched, we all started with one single instance, which is M1. Now we have over 270, more than 270 instance types on EC2. So with this kind of wide selection of EC2 instances, a lot of customers ask us, what's the difference between these instances and how do I choose them? So now let's do a very quick view of the EC2 instance types that are available in AWS. So there are 5 categories of instances that we offer today. The first one is compute optimized instances, which provide very high CPU power for compute-intensive workloads. For example, things like HPC simulations. We have memory optimized workloads, instances that support applications that require a lot of memory, for example, in-memory cache. We have storage optimized instances that are designed for applications that require higher read and write speed to very large data set on local storage. So for example, like D2 and I3 and H1s are an example of these. And then we also have accelerated computing instances, which provides either FPGA or GPUs for workloads that requires a lot of parallel processing powers, for example, machine learning trainings or inferences. So with 270 and counting instance types available in AWS, a lot of customers ask the question, how do I make sure that I'm using Amazon EC2 optimally? So there are a lot of considerations that goes into instance selections. So if you think about this problem, the problem is really an optimization problem that is somewhere between art and science, right? So everybody wants to get the biggest bang for the buck, but you don't want to over-provision because it can lead to unnecessary costs. You don't want to under-provision because you can get paged at night. So to make a good choice, you have to have a good guess of what your workload actually needs. So every workload requires a minimum amount of resources, for example, CPU, memory, disk, storage, network. So if you run HPC workloads on T3, for example, then it's probably not going to work very well because it needs a lot of compute and probably should run on C5. So you also need to understand what is the cost requirements of your workload. So if I have unlimited budget or money, I would like to run all my workloads on X1E or I3, 16x large, just pick the largest instance I can find in EC2. But this is unnecessarily wasteful for most of the workloads that only requires maybe 1 or 2 vCPUs or maybe 10 or 20 gig of memory, right? So you have to keep a balance between the performance of the instance and the cost of the instances. So There are also other considerations. For example, you need to understand which instance type is available in which availability zone or region. So not all the instance types are available in all the regions, AZs. So you also need to understand some of the nuances. For example, certain instance types, for example, T3 instances may not be available as dedicated tenancy. So if you want to have dedicated tenancy, you probably can't use T3 instances. And then you also need to consider, like, if your operating system is compatible with the instance, like certain armies has a very strict requirements on what kind of instance it can run on. So when you have initial guess and you start your application, it's not easy to get everything right at the beginning, right? So your initial guess may be undershooting the mark, overshooting the mark. So you need to continuously monitor what your instance is behaving and make adjustments. So this process is a process we often refer to as right sizing. So you need to continuously monitor what the workload performance is and analyze the resource utilization and then make changes and then do it again when your workload profile change or you have more customers, when you promote things from UAT to prod. So whenever you have any change to your workload, you have to do this continuously. So in AWS, we also provide a wide range of purchasing options. So we offer things like on-demand instances, which gives you highest flexibility. You can terminate at any time. You can launch at any time. You build by second. We have spot instances. If your workload can tolerate interruptions, we allow you to get a very deep percentage off from your on-demand pricing. We also offer reserve instances and savings plan that you can check it online. So there are a lot of other sessions that talk about the purchase options, so I'm not going to talk too much about it. I really want to talk about what are considerations when you look at the instance, to choose instance from instance capability point of view. So each instance has a lot of dimensions. The first two dimensions I want to talk about are CPU and memory. So if you draw the CPU and memory on a chart like this, you can see that for a large range of instances like M, C, R, T, X, it's mainly about the trade-off between the CPU and memory ratios, right? If you really want a high memory, then you should really use things like X1Es or R5s. If you need a lot of compute, you probably need to focus on the C4 or C5s. Just focus on the dimensions that matters most to you. And then another thing I want to mention is that in AWS, by default, we offer a lot of monitoring tools like CloudWatch metrics, allow you to give you visibilities into what the instance are currently behaving. There's only one metrics that is not offered by default that will be super useful for the right sizing process, which is memory metrics. So in order to get visibility into your memory metrics, you need, because it's internal to operating system, you need to install CloudWatch agent in your instance to get visibility into it. So there is a special class of instance in the general purpose instance family, which is called the Burstable instance types, or T instance types. So Burstable instance types provide you a baseline of CPU performance and allows you burst your CPU usage at any time for as long as you want. So if your average CPU utilization is below the baseline, then you can run it on the T, which is cheaper than the otherwise equivalent M instances. And there are two modes for the T instances. One is unlimited mode, one is a standard mode. Unlimited mode really allows you to burst above the baseline for as long as you want. If your average CPU utilization ends up being higher than the baseline, you pay a small extra fee for the extra CPU credits. So it's essentially, it's like every second we top up certain amounts of credits into a bucket, and then whenever you use CPU, you drain the credits from the bucket. And overall, if you have a surplus in your bucket, then we won't charge you extra. If you have a negative balance in the bucket, then we'll charge a little bit extra for the extra CPU credits that you used. So T instances T3 starts in unlimited mode by default, so that it really gives you very good insurance of your workloads in case there's some unexpected spikes. So if you want to make sure that you only pay for the instance itself and you want EC2 to throttle your CPU performance, in case you have a sustained burst, then you can choose the standard mode. So other than CPU and memory, there are also other dimensions of the CPU of the EC2 instances. For example, the network bandwidth, the EBS bandwidth. So I'll hand over to Nick to talk about these dimensions in detail.
All right. So when you start thinking about your instance, and particularly when it comes to networking, there's a few things you want to think about. So each family of instances and each size of those families of instances has particular network characteristics. So each one has a bandwidth capability. It also has things like a packets per second capability. And so generally speaking, as you go larger inside a family, you're going to get more bandwidth, you get more packets per second. And generally, as you have newer and newer families of instances, they get better at doing networking. So they get better packets per second, they get more bandwidth, those kinds of things. So if you're network bound, often the easiest thing to do is either go to newer instances or bigger instances. And doing the testing, I'll show you a little bit about how you actually sort of determine that kind of thing. And the instances themselves also have different underlying networking capabilities. So the newer instances have better driver support for things like the Elastic Network Adapter, or ENA. It also allows you to skip some of the operating system level functionality and push it into the hardware so you get better performance. And there's also a provisioned EBS bandwidth. So if you're accessing your storage into your EBS volumes, you do that over the network, and you want to make sure that that instance has enough bandwidth to do that. So from the EBS perspective, each instance has its own sort of provisioned EBS bandwidth. So you can take a look at that. You can take a look at your existing CloudWatch metrics and get an idea of where that should be and what it might be. Keep in mind that the actual IOPS you get out of an EBS volume is related to the overall size of that volume. And if you want more than what's provisioned, you can get provisioned IOPS. So you can get more storage and more IOPS out of that. And so at some point, there's this sort of balance between your networking and your storage where, okay, well, am I network bound or is my storage just not fast enough? And so that's usually where you end up doing testing, benchmarking, taking a look at the metrics and figuring out where that line's sort of drawn. And when it comes down to actual network performance, it depends a lot. There's a reason why there's not like these numbers out on the internet, because we have to ask a lot of questions to figure out, what is my network performance going to be? Well, there's universal networking stuff, which is an official term, by the way. But it's basically the fundamental laws of how things like TCP works. So there's something called like the bandwidth delay product, which basically means that for TCP, I have to send you packets. So if I throw you a packet and you're really far away, and you send me a packet to say, yeah, I got you threw it, I got it, and I throw you another one, like that game of catch, if we're really far away from each other, the bandwidth is going to be depending on how big that packet is that I throw to you. If you're in space and it takes a second, then no matter how big that packet is, we're never going to get high bandwidth. And so what a lot of people sort of don't realize is like, hey, I seem to get less bandwidth from Virginia to Singapore than I should. Well, okay. Or are you playing with your TCP settings? Like that bandwidth and that latency is a lot longer, and TCP doesn't natively scale up very fast in that scenario. As opposed to like if you use UDP, UDP will just sort of shoot packets off without requiring any response. So you can use UDP to sort of differentiate if TCP might be your bandwidth problem. There's also packet loss. So TCP, whenever it loses even a single packet, will often reduce the entire bandwidth down by half. So any amount of packet loss can kill your bandwidth. There's other things like scaling windows, your implementation details inside the kernel. There's different TCP implementations like Reno and Las Vegas and things like that that change the way that TCP works. The MTU, so if I'm throwing packets, how big is that packet? We can do up to 9,000 inside of a VPC or peered VPC. But over the internet, it's going to be 1,500. So inside your application, that also matters. So what's the relationship? So every time I make that network call, is it related to an expensive storage read or write? What's that relationship between CPU, memory, and network? It's something that's pretty hard to really determine in detail. And there's certain optimizations inside your application you can do as well. So there's better driver support. So within the instance, you can enable things like enhanced networking. So on the older instances, like C4s, C3s, M4s, they have the option of enhanced networking, which uses the Intel driver, the Intel 82599 driver. That gets you better networking performance. On newer instances, the newer Nitro instances like C5, M5, it's based on the Nitro platform, which I'll show you. But that requires you to use the ENA driver. And so that's sort of mandatory at that point. So older instances may not even use enhanced networking. There's other things you can do, like Intel's DPDK kit. So that basically allows you inside your application to skip like the operating system calls and go directly and control the network driver directly from the application. So that's for like, really sort of intensive networking applications. And that gets you better packets per second, lower latency, lower jitter, that kind of thing. And what we're talking about like microseconds at that point. And then you've got all the sort of AWS componentry, which isn't as global. It's specific to our implementation. So like I said, your instance has some capacities about it. Things like if you're running on the newer Nitro instances like the C5s, they have a network I/O credit. So when you first spin it up, you're sort of given like the burstable stuff. You're given a credit of bandwidth, and the more you use your network, the less those credits go down until eventually you sort of get to your established baseline. And so that's a different sort of thing you want to think about when you're doing testing. Same thing if you're using burstable instances. If you talk about the latencies, so between availability zones is generally like sort of single-digit milliseconds, but across regions that can change, and that can change your bandwidth delay product, or if you're using CloudFront, those kinds of things. There's also sort of the architectural stuff. So if you're using transit gateway, there's a bandwidth limit of around 50 gigs per attachment. If you're using network load balancer, you start off with 5 gigs, but it can scale upwards. If you're using NAT gateway, it's around 10. The VPC itself doesn't have any bandwidth limits, which is good. Neither does the internet gateway. Some people want to add like additional network interfaces because they think that adds bandwidth. It doesn't. So there's like AWS specific things that you might have to do a little bit of research on. Another one is if you send traffic outside your VPC from a single instance, it's going to be limited to 5 gigabits per second. So you're not going to ever do like 25 gigs to the internet out of a single instance. But you could do it to S3. You can go from an instance to S3 with 25 gigs. So there's just sort of like some AWS limits that may be impacting you. So the lesson is you have to go test it. It's really hard to take all those factors into account for your, especially for your networking componentry. So to test that, here's some tips. So iPerf is pretty good at testing. So you can use iPerf, use the -P, the capital P, and that will do multiple flows. Because a single flow is limited to 5 gigabits per second, but if you do multiple flows, you can hit higher limits. And so the capital P, sometimes I'll try 5, 10, 15, 20, 100 just to see what it does to my flow. Because that also uses different queues on the networking. It uses different paths inside our infrastructure. So there's lots of ways that different flows help. You can also use UDP. So that helps you test like, the packets per second, helps you test the raw bandwidth that you can do, and gets rid of some of the latency concerns as well. Because now you're just shooting packets out, and you're not requesting for someone to throw you packets back before you send more. There's this distributed load testing tool. So this is a CloudFormation template you can run. It deploys basically a web console and a container system. So you can do like transaction testing inside your VPC. It doesn't have any additional cost. I mean, just whatever the CloudFormation spins up, so you pay for the containers or whatever. But it's something we've just given to customers. And then there's some pretty good links here in terms of what you can do for testing, some more detail. And then inside the operating system, there's other things you can do. You can do TCP tuning. You can do, whether it's Windows or Linux, you can change the TCP optimization, congestion windows, that kind of thing. So if we take a look at the actual hardware that we have, so we're a cloud. We have hardware. Huge surprise. And if we go through the different generations, so the previous generation, this is the CC2. So if we go back in time, pre-Nitro. Because we're a cloud, we have to do things like we do billing, we do monitoring, we do DNS, we do storage, we do a bunch of things. And that all runs in DOM 0, which is essentially like the overhead portion of it. And then the Zen hypervisor does the virtualization. And so that works. That let people run VMs. But it wasn't as performant as it could be. So then with the C3, we started doing some of the Nitro work. So we took the networking and had an 82599 card that you could use with enhanced networking. So now you can skip that virtualized networking and go and directly use the network card. So it gets you better networking performance. And then with the C4, we did more. So we took some of the storage components and we pushed that off, and now we have storage optimized with EBS in the C4 instance. So we took that a little bit step further. And then with the C5 instance, for example, we changed the hypervisor out. This is a total rewrite for us, basically. So we're no longer using Zen. We have a Nitro hypervisor. And all of the componentry that we had in DOM 0, we put on hardware. So we bought a company called Annapurna a while back. So we're able to put basically specialized hardware in these hosts so that everything you want to do from a cloud perspective, all our management, all of that metering, monitoring, DNS, networking, storage, virtualization, that all happens in hardware. So we don't actually need a hypervisor anymore, which is sort of how VMware Cloud works. So we run all of, essentially the hypervisor and all the cloud functions on hardware, which is great if you really care about performance, because now that's way less overhead that we have to do. The hypervisor is there just for the virtualization, and that's it. So it's less overhead and more space for computing. So you can get, just moving from like C4 to C5, for example, you tend to get a lot more bang for your buck there because there's less overhead, especially if you care about like really high performance, HPC, that kind of thing. But it does require you to use now our drivers. So the ENA driver is mandatory, NVMe support is mandatory, because that's part of how that hardware works. So yeah, new hypervisor, less overhead. If we take a look at the numbers, so if you take a look at the storage bandwidth, here you can see from C3, C4, C5, we went from 10 to almost 40 in terms of just raw bandwidth numbers. If you take a look at the latency, so both the average latency and the TP99, which is sort of like the 99th percentile of worst case sort of latency, we've reduced, one, the latency pretty dramatically over these different instances, but we've also reduced the variability of latency. So the average and the worst case has gotten really, really narrow now as we've offloaded these things into hardware. So here I'm going to pass this over to Letienne, who's going to talk about the Compute Optimizer, which is the cool part.
Thanks, Nick. All right, so with so many dimensions and factors to consider, like CPU, memory, disk, like EBS, bandwidth, network bandwidth, all these parameters. So a lot of customers ask us, can you make it easy for me to choose what is the right instance type for my workload? So yesterday we have announced a general availability of a new service, which is called AWS Compute Optimizer, which helps you do exactly that. So looking at the AWS history, we always look for ways to make things easier for you. So a couple of years ago, we launched AWS Trust Advisor to offer 2 checks, which is high utilization CPU utilization, Amazon EC2 instance check, and low utilization Amazon EC2 instance check. So essentially, it helps you identify the instances that has a very high CPU utilization that you may be considering purchasing a larger instance for it, or an instance that's pretty much idle and you should consider terminating or downsizing it. Earlier this year, we took a step further and launched AWS Cost Explorer right-sizing recommendations, which helps you to identify underutilized EC2 instances that may be downsized within the same instance family, and help you quantify the potential savings, inclusive of reserved instances and a savings plan. So a lot of customers have asked us for recommendations beyond just downsizing with the same instance family, and then AWS Compute Optimizer delivers a functionality to help you identify the optimal EC2 instance type for your workloads. So by using the service, you can lower your cost and improve performance of your workload. You can take advantage of the insights from Amazon's millions of workloads to optimize your workload. You can easily compare and select different optimal instances for your workload. So it makes downsizing recommendations within the same family or across different families. It makes upsizing recommendations to remove performance bottlenecks and recommendations for EC2 instances that are part of auto-scaling groups. So it provides additional capabilities to enhance the recommendation quality and user experience for the infrastructure operators. It provides you a performance risk score to help you understand what is the trade-off between cost and performance. It also provides features, things like projected utilization time series, because a lot of times when you talk to an engineer, can you downsize this instance, they'll ask a ton of questions like, is it going to restrict my CPU? Is it going to have sufficient performance for my workloads? So AWS Compute Optimizer helps you answer this question as well. So at a high level, a service ingests the configuration data of your AWS resources. So things like the tenancy, whether it's part of autoscaling groups, and all sorts of information. And then it also looks at the CloudWatch metrics. So if you have CloudWatch agent installed and use the default namespace, the CW agent namespace, we'll consider memory metrics into consideration as well. It then analyzes all these data and then to provide you up to 3 recommendations, and it project the CPU to memory utilization of your workload on various instance types, and then choose the best one for you. So now let's do a quick demo of the service. So when you first start using AWS Compute Optimizer, the service is an opt-in service. So you will need to explicitly opt in for your account. So you can opt in just for your current account only, or you can opt in for all the accounts in your organization. So this is the opt-in page. And then once you review all these information, you can click opt-in. So I have once you click opt-in, then it will take about 12 hours to generate all the recommendations for your account. So this is an account that have not opt-in. So I have a prepared account that has recommendations for it. So this is a dashboard you will see after 12 hours. So you will see all the EC2 instances that we have recommendations for, and you can see the auto-scaling groups that we have recommendations for. The console is a global console, which means that you can select multiple regions. And then you can select you can select accounts in your organization if you have an organization account. So it simplifies the workload for infrastructure managers because you don't have to toggle and switch and log in and log out different accounts. So here there are 2 parts. So one is EC2 instance parts, and we classified EC2 instances into 3 categories. One is under-provisioned, one is over-provisioned, and one is optimized. So let's look at the instances that may be over-provisioned. So once you click on that, it gives you a list of all the instances that are over-provisioned. So it shows you what is the current instance type. For example, this one is running an M5 X-Large. Compute Optimizer thinks that it's over-provisioned, and you can run it on R5 Large. The current on-demand price is 19.2 cents, and you can run it on R5 with 12.6 cents per hour as on-demand, and you can save this amount. Then you can configure the columns to not only show the on-demand prices, you can show the reserve instance 1-year RI price and 3-year RI price. You can exclude instances that belong to auto-scaling group because they would need some special treatment. You can also look at the RI coverage and RI utilization so that you can analyze whether you will need to convert RI after you make the change. So now let's look at an example. So this is the detail screen that shows you for this particular instance what are the recommended options. So it's currently using the M5 2X Large. The average CPU utilization, if you look at the chart, is around 10 to 15%. Over the last 2 weeks, you can look for things that has a shorter periods. If you look at last 3 days, you can see it's bouncing around between 10 to 15%. You can actually run it on R5 X Large with half of the vCPUs. So at the moment, you have 8 vCPUs. You can downsize to an instance with 4 vCPUs. So here, there are 2 lines here. The blue line shows the current utilization for the past 2 weeks, and the green line shows, had you used R5, what would the CPU utilization look like? And it helps answer the question like, am I going to be throttled by CPU? In this case, probably not, because the projected utilization is below 25%. So you're pretty safe to choose an R5. If you have memory metrics available here, it will be displayed here as well, and we take that into account into analysis. But this instance does not have a CloudWatch agent installed, so it shows data unavailable. And then you can click this button to go to the EC2 console, which you can stop, modify, and start instances in the EC2 console. Now let's look at the auto-scaling groups. So for auto-scaling groups, we have two findings. One is not optimized, another one is optimized. So not optimized means that there is a better instance type for your auto-scaling group. So for example, this one you're currently using the C5 XLarge, that is 17 cents per hour, and your group size is 4, so the design number of instances is 4. So you can run it on T3 or M5 or R5. All of them will save you a significant amount of money. If you choose T3, it will save you about 51%. And if we look at this average CPU utilization of the group, this is the group level metrics. It's pretty low, so it's pretty safe to downsize this. So in terms of the metrics that we analyze a wide range of CloudWatch metrics. So if memory metrics is available, so you can use the default CloudWatch agent configuration and publish to CW agent namespace. We'll pick that up. If you're not using CW agent, CloudWatch agent, then you can also publish metrics by publishing to the same dimensions, using the same dimension namespace, and then we'll pick it up as well. Here we also have a field called performance risk, which helps you understand when you change from C5 to T3s, what would be kind of the overall risk assessment. So here we have performance risk as median for T3, very low for M5 and R5. This reflects that T3 is, there's some performance variability that you will need to test for your applications. So that is how the console works. And then all these recommendations are available through APIs. So you can just use open AWS CLI and just give you an example. AWS Compute Optimizer get EC2 instance recommendations, which gives you all the recommendations for the EC2 instances. Then it shows you JSON, which essentially has the instance arms, the recommended instance types. This is the current instance types, and these are the things above are the recommended one, the R5 XLarge. And then you can essentially export all the recommendations through JSON file. You can do whatever you want. You can put in a CSV, or you can import in. You can write some script to import into CloudFormation templates. So there's endless possibilities once you have the API experience. So now let's go back to the presentation. So with AWS Compute Optimizer, so right sizing is not something that you click a button and it's something that's optimized for you, right? So you have various tools. You have AWS Compute Optimizer, you have Cost Explorer, you have Trust Advisor. So all these AWS services help you identify what is the optimal EC2 instance for your workload. But in order to realize the savings, you still have one step, which is you actually have to have people to implement all these changes and validate the performance of the performance characteristics of your workload and make sure that everything will work fine after you make the change. So let me introduce Renan, who is the Director of Engineering at Nubank. And he has some excellent story about how Nubank approached the whole right-sizing process. Welcome.
Thank you. Hello. Hey, are you okay listening to me? Okay, good. So as Letian mentioned, my name is Renan Capaverde, and I'm Director of Engineering at Nubank. Any of you know Nubank already? Okay, just a few hands. Awesome. So for those that don't know it, Nubank is the leading financial technology company in Latin America, and we're also the largest independent neobank in the world. You probably don't know it because we're not as known here in the US. And I'm going to explain a little bit of our business because this is important for you to get some insights on your right sizing and cost optimization strategies, some of our architecture as well. And I hope to share some lessons that we've learned that could be useful that you can implement right away with, in your company as well. So just to explain a little bit, our products have changed the life of 17 million people in Brazil. We provide a fully digital experience through the mobile app by enabling people to take control of their financial life. So everything from managing purchases, invoices, everything being done in real time with a no-fee approach. And in Brazil, around 60 million people are unbanked. And this means that for the incumbent banks in Brazil, they are just not profitable because of their physical branches and inefficiency. But with Nubank, you just need a smartphone and an internet connection to be part of the formal economy. So that's huge in terms of democratizing financial services. And all this technology approach with no-fee approach comes together with a humanized service through the chat, email, and app. And well, the main reason I'm putting this slide here is that we've seen exponential growth. We're not a very old company. We're 5, 6 years old. And scaling is hard. You probably know that. And this thing that we did by growing exponentially, we did it with maintaining one of the highest NPS in the industry. And the bank credit card offering was started like 5 years ago. And it's not that old, but our scale is already massive. And with massive scale, you have massive cost optimization opportunities as well. And this curve here shows the number of customers in yellow and the normalized cost in blue. And this AWS cost curve was growing too steep. And I think probably some of you have some similar stories. That's why you're here in this session. But this caught the attention of our finance team, and they wanted to understand why are these costs increasing so much? Who are the main offenders? Can I see this cost by customer? Can I see this cost by product, by team, business unit, you know? They wanted to understand how much can we save in terms of money? What can we do about it? And can we see the forecast for next month, next year, next 5 years, you know? And our journey developing this cloud cost optimization management has had a lot of different moments. And I'm not going into many details here, but we've come a long way from almost zero visibility and lack of reserved instance coverage to a fairly complex cloud cost management process with some good results and a semi-automatic right-sizing process workflow that I'm going to go deeper in a few minutes. But during this journey, we migrated our infrastructure to a cell-based architecture for scaling purposes. You've seen the scaling part. And the cell-based architecture is important in this because it was good for scalability, but it was not as good for efficiency. And in the cell-based architecture, we basically duplicate or create multiple clones of our infrastructure that handle different types of customers or different groups of customers. So the infrastructure is basically the same, but in terms of load and performance, they differ. We also perceive a big knowledge gap from the finance team when it comes to AWS cost mechanics and pricing model. It's not something that's easy to grasp. But we eventually hired a full-time employee to manage our cloud expenses. It was something that was really good for us. And we also migrated to Kubernetes. Many of you have done that or are planning to do that. So I'm sharing some stories on how went for us. So it was good in terms of velocity, scalability, reliability. But for cost allocation and attribution, it brought some meaningful pain points. And I'm going to tell a little bit about that. So we had to develop our intuition as a company to actually ensure that we could evaluate the initiatives that we're going ahead with. So for the business side, we decided on some business metrics. And for our context, it was very important to know the cost per customer, the cost per customer per business unit. We wanted to see the actual cost versus the forecasted cost because we're a Brazilian company and the taxes are huge and you have the exchange rate when it comes to dollars, so we need to keep good track of that. And we also want to track the number of future opportunities, their size and their impact. We want to know if we're prioritizing correctly and staffing correctly because there might be some initiatives that it's better to put 10 people working on than others. And in terms of cloud metrics, that's more on the tactical side. We want to understand how our efforts were going. So we're measuring reserved instance coverage, the percentage of untagged resources, which we wanted it to be zero, right? We wanted to give costs the owners. We want to see the number of microservices that are within our right-sizing recommendations. That's very important. And of course, the number of idle resources, which is basically waste that we could delete and we're not deleting. We also want that to be 0. And if you take a look at our main metric in terms of business, which is the cost per customer, this is normalized using August 2017 as the index. Well, during this period, we expanded customer base, improved the product offering, feature availability, and we did it keeping this fairly stable cost, let's say. So we went from 100 microservices to 350, and from 2 shards or 2 cells to 15. So we grew a lot, but the cost for a customer didn't grow that much. And if we were not on top of our costs, it would be really impossible for us to keep this stable, right? That would go bananas. So you can see on the far right of the screen that there's a big change in the slope of the curve. And this is after we implemented this semi-automatic right-sizing process and these Kubernetes improvements. And we actually don't expect it to go to 0, of course, but expect to reach a new baseline, then find the future opportunities and get a new baseline afterwards. So how can you, here in this session, drive changes and results to your company? So the playbook, basically, that we try to follow is that we have to migrate workloads that are on demand to different purchases model, like a spot instance, reserved instance. That's one way to do it. Second thing is eliminate waste. We should not be paying for things that we're not using. And third, we should right-size your workloads. And that's the playbook, that's the theory. But when we go actually from visibility to actionability and from theory to practice, in the companies we are in, we actually have to focus a lot on stakeholder management. We have to rely on automation. We have to develop our automation so you can automatically allocate the costs all the time. You have to do sometimes a cultural shift because you're not going to do all these changes in the company by yourself, by your team. You have to execute changes through the others. And all of that is kind of wrapped in this continuous improvement loop, and you will get better and better. And going deeper in the right-sizing concept and challenges, right-sizing is basically the process of getting the best resource fit for an application or infrastructure. And with the cloud, we pay based on what we provision and not on what we use from what we provision most of the time. So if we could use and provision exactly what we need, then we would get the best value for money that we can. And this is not easy because many times we over-provision for redundancy, reliability, we provision for peak capacity instead of scaling with demand. And many times there's an engineer that puts this 5x factor just to be safe. And you know, it happens. It's real life. And what we want to do is we want to empower engineers. We want to give them visibility, be right there in the right feedback loop, and ensure the incentives across the company are aligned. And we need to make them understand why right-sizing matters. So there's a big effort on education. And these small things with 1,000 teams, 100 teams, tens of teams, they sum up to big amounts. They are small, but they sum up to big amounts. So we should not be trying to own their backlog, but we should try to make the tooling better, the automation better, and put this big effort on cultural shift. So our first approach to right-sizing was very, very manual. And it's okay to do that, especially in the first step. It's basically the first step that every company should begin with. And in this process, we had this full-time employee, an AWS cost analyst that would go to AWS reports and treat and clean the data, check the right-sizing opportunities, create dashboards, analyze the data, and then schedule presentations with the feature teams, with the product teams. And from the engineering point of view, these engineers would attend to the presentation. After a while, they would put the recommendations on execution plan in their backlog. And eventually, perhaps one day, you know, they would do it or not, I don't know, because it's their backlog. And how do you follow up on that? And this manual approach was good for a while, but it has some issues, right? And I think one of the greatest things that AWS is doing is with the launch with AWS Compute Optimizer is that this manual step of treating the data, analyzing it, they're doing it for us. So it's easier to get started. This first step of analysis is easily done, so try that out. But thinking of ways we could improve that process, well, we want it to be more easily scalable, more automated, and easier to execute and implement. And we thought that if we did all of that and inserted the right feedback loops into the developer workflow, we would reduce the lead time, which was really high, and the effectiveness of the changes we wanted to perform. So ensure that the things are actually being executed. And I'm happy to share with you that by changing the process or using this new process that we developed, we reduced the lead time from 60 days to an average of 5 days. So huge amount of results for us. So to explain a little bit of how that works, we have this central repository that we use where we declare our microservices and their workloads, right? But there's this other thing that we have here, which is the applications running or the runtime. And there's this monitoring tool that we use called Prometheus, which is an open source tool that monitors Kubernetes workloads, basically, and many other things. So what we did is that we put those things together. We actually had a script that would check for the service or for the application what they were being provisioned with and what they were actually using. And this script that we created was able to do that with not a lot of fancy logic, just some smart, quick things. And there's a lot of room for improvement there. But what we did that's really powerful is that it automatically opens a pull request in the central repository, already implementing the suggestion for the right sizing recommendation. And that's really cool, because what we actually did afterwards was that we put this script as part of our CI tooling, so embedded into the developer workflow. So if a developer is changing their applications in terms of microservice workload or configuration or anything like that, this test is running. If you are over-provisioning, the test fails. So this is like the feedback loop just on the spot. And then the engineer would change that, and there's this command that actually executed change for them. So this led to 40% of our microservices being right-sized in the first 3 months. And this is very cool because we have 350 microservices. So if we did that by ourselves or with an analyst, that would be really painful. And talking about the cell-based architecture that we have, one thing that's important to understand is that for tens of different cells, what the engineer will do is to provision the capacity for the workload based on the highest resource need and not fine-grained detail that. So what would happen is that the highest need would dominate all the others, and then for the other cells it would be over-provisioned. And well, we can see that in this screenshot here, this is the right sizing of our script. And there in the current workload, you can see that for the main shard, we were using, compared to the other ones, 8 times more memory, 8 times more memory in twice as much CPU than we actually needed. And for a human, it's really hard to go into these fine-grained details and complexity. And prior to that, only humans would be changing this file. But now that machines are doing it, it's more inexpensive because machines are really good at dealing with complexity and fine-grained details of repetitive tasks like unit testing, linters, you know. And humans are not. They lose focus. They tend to avoid the effort even when the rewards are potentially huge. So there's a step. That's the first one, which is based on manual work, but eventually you have to automate. Automation is the future. And another problem that we had, it was related to frustration, right? So the cost optimization journey is not linear. And remember that bumpy AWS cost per customer that I showed you? Well, to improve infrastructure, we actually have to create infrastructure to test it. And when you're doing that, you actually have twice as much infrastructure. And twice as much infrastructure, it costs. So the main reason I'm putting here is because when we were migrating to Kubernetes, we had the old infrastructure and the new infrastructure. And there was a time where we had to test it and ensure that the reliability was there, all the controls were there. And eventually, we killed the old infrastructure, and we had a new infrastructure, which was good. It was reliable, it was scalable, but was not as efficient as the old one because we've been running the old one for some time, and we have already optimized that. So now we have a new baseline with the new infrastructure, and then we have to optimize it again. And another aspect that Kubernetes provides us is the flexibility. So we were using, at first, after the migration, the same EC2 workload requirements for the container because it was easier for us to do that in that way. But in the EC2 world, we had the log forwarders, we have the monitoring tools, all the sidecars, we had the operational system, and this was not being used by the pods in Kubernetes. So this space that was actually provisioned, it was not occupied. So eventually we were able to make our workloads for the actual applications smaller because we were sharing those log forwarders within a Kubernetes nodes. And thinking of flexibility, another thing that Kubernetes brings us is an aspect of having an application that's half a CPU and 20 gigabytes of memory or something like that, which is more flexible than using the previous created types of workloads that EC2 instance has. So this flexibility might be important to you. And to do a quick recap here on a lot of things that I've mentioned. First, you have to define your metrics and your goals for your own context. It could be cost per view, cost per impression, cost per customer. You know your business better than me, but find a common main driver for your cost. It's going to be an estimate, it's not going to be accurate, but find it. Second, cost management might require a cultural shift because you won't win this battle alone. You have to educate your finance team, you have to empower the engineers of your company, and you have to have some empathy because some people are not going to prioritize your cost reductions. And it's okay because they might be adding more value to the company by creating more revenue than by reducing costs. Be mindful of that. Third, start manually, then think of automating things. Try out AWS Compute Optimizer. It might be really helpful to you. Fourth, this cost optimization journey is not linear. So it's good to understand that so you don't get frustrated. Okay? And finally, I think the most important message here is that right sizing is a process. It's not a project. When you finish, do it again, then do it again, then do it again. You get better and better with each iteration. Costs are like fingernails. You have to cut them continuously, okay? So thanks, and back to Nick.
All right. Cool, thanks, Renan. So let's say we've gone through this whole process and we want to change our instances out. What do we need to think about, right? So we talked about a little bit about sort of the Nitro changes and the hardware changes. The big one is, hey, when I go to C5, M5, R5, one of the newer instances in roughly the last year or so, they do have a different hypervisor, storage, and networking components. So there's some sort of CLI checks you can do here to see if your operating systems and things are compatible with the new versions. If you're on most of the common distributions of the Red Hats, Ubuntus, Amazon Linuxes of the world, it's been built into those kernels for a year and a half-ish for the most part. So you also have to change a little bit of the EBS volumes here, so I got a command where you can go check that. And then in terms of the ENA driver, these are some things you want to think about. So it's pretty cool, actually, if you're a networking geek like me. We've changed a bunch of things in the underlying hardware that make the networking better. Lower latency, lower jitter. Here I've got some of the operating systems and where we introduce support for ENA. It's also out here on GitHub, so if you run some sort of bespoke operating system, you can patch those kernel changes in. And there's actually a V2 of this, which does some other cool things. So if you're going to be patching, try to get that in there as well. So thank you, everyone, and appreciate you coming. And we'll be up here for questions if you want to come up and ask any questions.